Download this code from codegive.com, link in the description below. Creating resilient web applications is crucial for ensuring that your service remains operational and responsive, even in the face of temporary issues like network failures or service unavailability. One common strategy for achieving resilience is the use of retries. In this tutorial, we'll cover the principles of implementing retries and provide a code example. Principles of resilience with retries. 1. Understanding retries. Retries involve attempting a failed operation again after a specified delay. This is particularly useful for transient errors, such as network timeouts, temporary unavailability of a service, or rate limits. 2. Backoff strategies. Implementing a backoff strategy is essential. Instead of retrying immediately, wait for some time before the next attempt. Exponential backoff is a common strategy where the wait time increases exponentially with each failure. 3. Maximum retry count. Always define a maximum number of retries to avoid infinite loops and excessive load on the system. 4. Error handling. Differentiate between types of errors. For instance, do not retry on client errors, HTTP 4XX, like 404 not found, but do retry on server errors, HTTP 5XX. 5. Logging. Log the failures and the retry attempts to monitor the application's health. 6. Circuit breaker pattern. In addition to retries, consider implementing a circuit breaker pattern to prevent overwhelming a service that is already struggling. Example: implementing retries in a web application. We will create a simple web application that makes HTTP requests to a fictional API. We'll use Python with the requests library for making HTTP calls and implement retries with exponential backoff. Step 1. Install required libraries. Make sure you have requests installed. You can install it using pip. Step 2. Implement the retry logic. Here's a simple function that makes an HTTP GET request with retries. Explanation of the code. 1. Function definition. The fetch_with_retries function takes a URL, a maximum number of retries, and a backoff factor. 2. Request loop. It attempts to make a GET request to the provided URL. If it encounters a 4XX error, it breaks out of the retry loop. 3. Error handling. If a 5XX error occurs or a network error is raised, it prints a message and prepares to retry. 4. Exponential backoff. The backoff time is calculated using the formula backoff_factor*, 2 retries, which means the wait time doubles with each retry. 5. Maximum retries. If the maximum number of retries is reached, an exception is raised. Conclusion. Retries are a powerful strategy for building resilient web applications. By implementing retries with exponential backoff, you can improve the reliability of your application in the face of transient errors. Always remember to log errors appropriately and consider additional patterns like circuit breakers for more robust solutions. Feel free to modify the example to suit your application's specific requirements, such as adding more sophisticated error handling or integrating with a logging framework.